Good morning to one and all. Myself Divya. Today my topic is about monopulse tracking radar. Tracking radar is nothing but measure the coordinates of target for determining the target path as well as it predicts its future coordinates is known as tracking radar. Based on the measured coordinates, error signals will be generated. Antenna should be moved based on an error signal to maintain the target within the beam. Tracking of range, angle, Doppler frequency shift, and radial velocity uses pencil beam. A- Angle tracking. Two beams are sequented crossover of beam bore side allows always maintain in the direction of target. Relative amplitude of two beams determine how far the target is from bore side. Also, direction in which beam needed to be reposted. Two beams in the both the coordination. Here we can see in the image beam 1 and beam 2. So beam position B and beam position A, and middle the separating line is tracking axis, and the dotted lines are known as beam axis. Methods of generating error signal: conical scan or sequential lobbing tracker. Time shares a single beam. Antenna beam is switched between two positions. Simultaneous lobbing or monopulse. More than one simultaneous beam is used for tracking is known as lobbing or monopulse. Usually four simultaneous beam to be performed two-dimensional tracking. Monopulse tracking radar. Radar in which information concerning the angular location of the target is obtained by comparing the signal required in two or more simultaneous beam. Two offset antenna beam are combined to obtain both the sum and difference signal. The signal are multiplied in a phase sensitive detector to obtain both magnitude and direction. Here we can see the image of amplitude comparison monopulse. So, here we can see that error signal is produced near PSD and video range signal there. Amplitude comparison monopulse. Two adjacent antenna fed are connected to two input arms of hybrid junction. So as we can see in the image, these are the two antenna which are connected simultaneously between at, and two arms of the hybrid junction. Sum and difference signal. Difference channel produce error voltage approx proportional to the angular deviation of the target from the bore site. Here in the images we can see overlapping antenna pattern and sum of and difference pattern, some transmitter and receiver, difference is only the receiver, amplitude comparison monopulse. By comparing the phase of difference, sum and difference signal, direction of an angle error is formed. So in the angle error is formed because of the sum and difference signal direction. Depending on these information, the servo meter will derive the antenna back to the target. Phase sensitive detector is used to compare the phase of two signals. In this image we can see monopulse in two angle coordinate. Here we can see transmitter, mixer and hybrid junction over the lower side, an amplitude detector, video amplifier, phase sensitive detector, phase ranging tracker, monopulse in two angle coordinate. The y-axis is azimuth bore site and the x-axis is elevation bore site. So in the image we can see four horn monopulse feed and the cubical part is monopulse comparator. So summation of A plus B plus C plus D is azimuthal bore site AZ is A plus C minus B plus D. Elevation bore site is A plus B minus C plus D. This is about two angle coordinates. All four feeds are used to generate some pattern such as A plus B plus C plus D. Azimuthal difference channel is A plus B minus C plus D. Elevation difference channel is B plus D minus C plus A. Two angle errors two angle errors, elevation angle error, output of phase comparison between sum channel and elevation difference channel, azimuth angle error is output of phase comparison between sum channel and azimuthal channel. So the name itself says that comparison between sum and the elevation difference, and azimuthal angle says that sum channel and azimuthal difference channel. Phase comparison monopulse. Instead of comparing the amplitude of the each of the echoes, from two sequented beams. The angle of arrival from a target is determined by comparing the phase difference between two signals. Uses two separate beams from two separate antenna looking in same direction. Phase comparison monopulse. An echo of boresight will arrive at two antennas. Boresight will arrive at the two antennas at the same time, and therefore the phase difference will be zero. So when they are having two antennas at the same time, then their phase is zero. An echo from a target in an angle q to the boresight will arrive at one antenna later than other antenna due to extra distances traveled. Phase comparison of monopulse. Extra distance traveled by one echo with respect to the other is given by x equals to d sine theta, or expressed as a phase difference delta psi equals to 2 pi d sine theta by lambda radians. Phase detector is used to find the angle error. Monophase phase comparison monophase. So this image says consists of transmitter, amplifier, envelope detector, angle error, phase detector, mixer. Comparison between amplitude comparison and phase comparison. Amplitude comparison has high SNR, 2 feeds at the force of single antenna, sequestered sequented beam used. Phase comparison is grating effect. High slide lobes are produced in some pattern, resulting in angle measurement ambiguity. Two separate antennas are used. Beams are not synchronous but look in the same direction. Thank you.